What if the cold shock that gives you goosebumps was doing more than making your skin react? What if that same survival response could tell us something about hair follicle stem cells, blood flow, and the biological switch that starts a new growth cycle? Today, we are going deep into the science behind cold exposure and hair biology, not as a miracle cure, but as one of the most fascinating new questions in regenerative scalp research. Before we begin, this is not medical advice. Do not freeze your scalp, apply ice directly to your skin, or use sub-zero devices without medical supervision. Cold water immersion can trigger rapid breathing, increased heart rate, blood pressure changes, and hypothermia risk, especially for people with heart or circulation conditions. For years, cold exposure has been marketed as a recovery tool, something for muscle soreness, inflammation, mental resilience, and longevity routines. But now, the conversation is moving from the whole body to specific tissues, and the scalp is not just a passive surface. Under the skin, every follicle is surrounded by blood vessels, immune cells, nerves, dermal papilla cells, and stem cell populations that help regulate the hair cycle. The big question is this: can controlled thermal stress send a biological signal strong enough to influence the follicle's transition from rest to growth? To understand the cold-hair connection, we need to start with goosebumps. When your body senses cold, tiny muscles attached to hair follicles contract. That reaction is connected to sympathetic nerves, part of your body's survival system. In a major cell study, researchers showed that the erector pili muscle and sympathetic nerves form a niche that can regulate hair follicle stem cell activity. The sympathetic nerves communicate with follicle stem cells through norepinephrine, a stress-related neurotransmitter. That does not mean taking an ice bath will automatically regrow hair, but it does suggest something powerful. Hair follicles are wired into the body's stress response network. Now let's move from nerves to molecules. When cells experience a controlled drop in temperature, they can activate cold shock proteins, including CIRP and RBM3. These proteins are part of how cells adapt to stress. In 2024, researchers tested controlled cold shock on mouse skin and also studied cells and human hair follicles outside the body. They observed increased expression of cold-inducible proteins and VEGF, a growth factor linked with blood vessel activity around follicles. In that study, cold shock was not random freezing, it was controlled. The researchers found that keeping post-treatment skin surface temperature in a narrow range was important, and colder was not automatically better. Cold first causes blood vessels in the skin to constrict. That is the body's heat preservation response. But under certain conditions, researchers have observed a rebound phenomenon called cold-induced vasodilation, sometimes called the hunting response. This response is best studied in fingers and extremities, not as a proven hair growth protocol. Still, it gives us a useful framework. Cold exposure can create dynamic changes in skin blood flow, and follicle biology is deeply tied to vascular support. Hair follicles cycle through phases: growth, regression, and rest. The transition into a new growth phase is not controlled by one magic switch. It is regulated by a network of molecular signals. Two of the most important pathways are Wnt and BMP. In simple terms, Wnt signaling is often associated with activation and growth, while BMP signaling is associated with restraint, timing, and quiescence. The balance between these pathways helps determine when a follicle becomes ready to grow again. So when we talk about cold shock, we are not saying cold replaces medical treatment. We are asking a more interesting question. Could thermal stress influence the follicle environment in a way that changes how these pathways behave? Now here is where we have to be precise. Minoxidil is an FDA-approved topical hair regrowth treatment. It has clinical use, labeling, dosing instructions, and evidence in humans. Cold shock is different. It is an emerging research area. The early biology is exciting, but it is not the same as an approved treatment for androgenetic alopecia. The smartest way to look at this is not cold versus minoxidil. It is, what can cold stress biology teach us about the scalp environment, vascular signaling, and future non-drug interventions? If cold-based scalp therapy ever becomes mainstream, it probably will not look like dumping ice water on your head. It would need precise temperature control, exposure timing, skin monitoring, and clinical testing. That matters because more extreme is not safer, and not necessarily more effective. In controlled cold shock research, lower skin surface temperatures were not automatically better for antigen induction. Precision is the point. And until human clinical evidence is much stronger, cold exposure should be treated as an experimental wellness concept, not a proven hair loss solution. So here is the real revelation. The future of hair science may not be limited to chemicals alone. It may also involve the language of the body itself: temperature, nerves, blood flow, stress proteins, and stem cell signaling. Cold shock is not magic. It is not a guaranteed cure, but it may be a window into how follicles listen to the environment and how future therapies could use that signal with precision. If you want more evidence-based deep dives into hair growth, scalp health, and biohacking science, subscribe, hit the bell, and comment. Would you try a clinically controlled scalp cooling treatment if the research proves it works?